Hello, my name is Ilya Baron, and I lead Onshape's architecture and FEATURESCRIPT team. And by the way, as I go, please type your questions and I'll try to answer them at the end. So today, I want to talk about the Onshape architecture and how that architecture enables Onshape's unique capabilities. I'm talking about things like the ability to securely share a design with someone across the world and to instantly start modeling with them, branching and merging, upgrades every 3 weeks, FEATURESCRIPT, integrated release management, etc. A couple of these, like not having to install anything, are simply consequences of our decision to have a system that you access through the browser. But most of what makes Onshape unique is the result of additional architectural decisions and careful engineering on top of that. And in this talk, I'd like to give you a peek at that. So first, what do I mean by software architecture? I mean the fundamental decisions regarding the design of the system. For example, our decision to have a cloud rather than a desktop installed product, or the decision to have a multi-tenant system. That means that Onshape users are communicating with a single system, sharing resources, rather than each user getting their own instance of the software. Without multi-tenancy, we'd have a lot more trouble with sharing, collaboration, maintenance, and costs. Two really important decisions we'll talk about are how is the system partitioned into its major components, and where does the data live and how is it structured? The architecture of a system usually has significant implications on things like functionality, security, reliability, performance, how well it scales, and how quickly we can add new features and fix bugs. So when making architectural decisions, we have to consider all of these factors. A key point is that architectural decisions need to be made early. It's like laying the foundation of a house. You can change a mature system's architecture, but that may be as hard as rebuilding the system. So let me illustrate my point with a quick trip down memory lane. Here's a screenshot of Onshape from September 2014. This was after less than 2 years of development. A month and a half earlier, we launched the production stack, which has been continuously running ever since. That's what you're all using. At the time of this screenshot, we had a small number of very friendly and patient private beta users. Now, it looks pretty similar to Onshape today until you look closer. In this version, we didn't have drawings, no loft, you can see the button is missing, no variables, it's pretty basic stuff, no sheet metal, of course. The ability to change part colors had just come out, so really bare bones. But at that point, already our versioning mechanism was fully in place. Multiple people can already simultaneously edit models. They can branch and merge. The big blue share button is there, of course, and the Onshape features are written in FEATURESCRIPT, even if the ability to make custom features has not yet been exposed. We hadn't yet shipped configurations, release management, enterprise analytics, but we had clear plans for all of them. Basically, our thinking was, look, most of us worked at SolidWorks. We know how to build a CAD system. So let's make sure to get the things in place that no one has done before, and then we can build out the CAD functionality. And the flip side of this is, if you're already starting with a legacy desktop CAD system, you can't tag cloud on as an afterthought. You can cloud wash the legacy software, but you won't get the types of capabilities that a true cloud solution gives you. So we can roughly classify other CAD systems by where the code runs and where the data is stored. In the lower left corner, we have desktop CAD, which is installed locally and stores data in files. And people are generally familiar with the pros and cons of that model. In the top right corner, there's Onshape. And then there are two halfway solutions that are often marketed as cloud, hosted CAD and thick client. With a hosted CAD solution, you rent a virtual machine with a CAD system installed, and you access it like a remote desktop. And that gives you some benefits, like access from anywhere, and you don't need to invest in expensive hardware, but it's still the same old CAD system with the same versioning, collaboration, and data management headaches, just on a different machine. A thick client is a CAD system that's installed locally and accesses data that lives in the cloud. You're still on the hook for fast hardware and upgrades, and version skew is still an issue. Sharing support is better, and there is some collaboration potential, but as far as I've seen, existing systems don't take full advantage of the database. So again, no branching and merging, no simultaneous editing, etc. But the takeaway is there's no incremental path from a hosted CAD system or a thick client to a full cloud system. If our competitors want to provide the benefits of a full cloud CAD system, they will have to build it from scratch, like we did. So let's look at our architecture in a little more detail. We'll start with the client, which is a part of the system that runs on your device and that you interact with directly. We have our browser client, which we develop in TypeScript, and it's the primary way users interact with Onshape. The client handles all of the UI interaction. When it's showing a part studio or an assembly, the client has the triangles of the model and draws them using WebGL. We also have our mobile clients, which are native apps for iOS and Android. They have full modeling capability, although some of the newer functionality lags behind the browser client. The clients talk to our backend, which consists of a network of machines that we rent from Amazon. And we just rent the virtual hardware, and we control all of the software that runs on these machines. The hardware itself is in physically secured data centers around the world. The first machines in our backend that you talk to are web servers, which handle things like serving up the client code, logging in, permissions, listing documents, plans and billing, account settings, etc. So what they don't do is they don't look inside documents. For that, we go to modeling servers, which are a group of machines that handle the interaction with an open document. These machines send feature lists, display geometry, assembly trees, things like that, over to the client. They handle user commands, like editing a feature or adding a new part to an assembly or merging from one workspace into another. They keep track of collaborators. They save all of the changes that a user makes to the database. And the thing that they don't do is the actual geometry computation. For that, we have the geometry servers. They run worker processes written in C++ using Parasolid, which is our geometry kernel, and DCM, which is our constraint solver, both licensed from Siemens PLM. And the geometry servers do regeneration, sketch interaction, assembly solving. They generate the display geometry as well as hidden lines for drawings. And they execute FEATURESCRIPT, primarily as part of regeneration. For the database, we use MongoDB. The stored data is encrypted, as is the communication with other machines. And it's continuously backed up with backups tested as part of our 3-week release cycle. So each of these boxes here represents a number of machines designed for redundancy. If one of the boxes fails, and hardware failures are a fact of life, some users may see a hiccup, like requiring a page reload, or they may not even notice anything, but the service itself stays up. These machines are also distributed around the world. So if you're in France, for example, you're talking to our servers in Ireland. And this is to keep communication latency down. Finally, we automatically scale the service up and down by launching more machines when demand goes up and shutting them down when they're not needed. Now, it shouldn't come as a surprise that this is a simplified picture. I'm skipping over logging and monitoring, search, drawings, caches, and a whole bunch of other things. But these here are the key components of our service. So what does this setup give us? Well, doing the UI and 3D graphics on the client means there's no network latency involved in things like selection, clicking buttons, or moving the camera. And these are some of the most common operations. Compared to other CAD systems that are primarily written in C++, most of our backend is in Java. And Java is a simpler language. You have to worry a lot less about things like memory management, and multi-threading is easier. And it's much harder to make the types of mistakes that lead to security flaws. Our geometry servers are the part of Onshape written in C++ because that's where you need the performance and power. That code is isolated from the client, which makes it much harder to attack. Also, in a desktop CAD system, which is usually a monolithic C++ application, if part of the C++ code or the geometric kernel crashes, as occasionally happens, the whole CAD application goes down, and if you haven't saved, you lose data. With Onshape, because the geometry server is separate from the code that writes to the database, if a geometry server crashes, you may get a support code, but no data loss. Another advantage of multi-tenancy is how efficiently we can use the hardware. With a desktop CAD system, you've got an expensive workstation that's mostly sitting idle while the engineer is looking at the model, getting a cup of coffee, or checking their email. We, on the other hand, have multiple users sharing hardware, taking advantage of multiple cores so that we can rent fast machines from Amazon and not pay through the nose. And what we found is if we add 100 active users, not just ones with accounts, but actually logged on, we only need to add a few extra machines to support them. So we have a lot of room to scale. We're not worried about Amazon running out of machines. So now let's talk about how we manage the data. We'll start with the obvious. What's in the database is the one and only source of truth. It's replicated and backed up to prevent data loss in case of disaster, but the database itself manages that. Viewed from outside the database, there's only one copy of each document. No questions about whether we're looking at the latest version or whether copies are out of sync, and no copies of your data accidentally left on a flash drive somewhere or emailed to someone. Another benefit of having all of the data in one place is that we can assign unchangeable IDs to everything we want to reference. You can name your document whatever you want, but it has an internal ID. And when you put a part from that document into an assembly in another document, that reference is stored in terms of this internal document ID. And that ID never changes. So your reference never breaks because you renamed a document or put it into a different folder. Even if you delete the document with the part, that reference still lives, going beyond the grave, so to speak, so that your assembly does not break. And this is actually a theme here. One of our most important precepts is the customer shall not lose their work. To make this true, when you edit an Onshape model, we don't overwrite anything. We only append your edits. If a desktop CAD system crashes or the computer shuts down while saving and overwriting a file, that file could end up corrupt. With Onshape, if the modeling server writing your edit to the database fails, or the database machine itself fails, because remember, hardware failures are a fact of life, well, that edit may not get written, but all of the previous ones are fine. And of course, we also use this to provide you with access to all of the previous states in the form of a document change history. So if you accidentally overconstrain a complicated assembly or delete some key features and can't figure out how to fix it, you can restore to the state prior to the mistake. And the final piece of the puzzle is how we store the edits themselves. Think of the entire part studio as a hierarchical structure, where you have features, features have parameters, and some parameters have multiple components, like a selection list having multiple selections. When the user makes an edit, we store it as a minimal set of changes to that hierarchy. For instance, if you edit a fillet radius, we just store that change, as opposed to, say, replacing the entire fillet. And these changes are flexible as to when they can be applied. If you deleted some other feature, you can still apply the fillet radius change. And this simple flexibility forms the foundation of simultaneous editing, because for most pairs of edits, it doesn't matter which one comes first. It also forms the basis of branching and merging, as we can take all the edits on one branch and apply them to another. And of course, it doesn't hurt that this is a pretty compact representation. Now, being cloud-based is not the only thing unique to the Onshape architecture. The way we turn features into a 3D model is built around FEATURESCRIPT, a programming language we designed for this purpose. FEATURESCRIPT lives inside Onshape documents in the Feature Studios, and all of which are in our database, and it's executed by the geometry servers as we talked about. All of our native features are written in it, and you have access to the source because it's in a public document. Of course, the major benefit to users is that you can use FEATURESCRIPT to write your own custom features, which look and feel exactly like the native ones. But it's more than that. One of the early decisions we made was that a part studio is itself actually a FEATURESCRIPT function that produces a 3D model when it executes. One of the consequences is a natural way to do configurations. Configuration parameters are just arguments to this function. So rather than have one giant table of parameter settings like some other CAD systems, this makes it easy to create a huge number of part variations. And the other consequence of part studios being FEATURESCRIPT is that a custom feature can call a part studio. And by using configured part studios, this lets you create a really flexible mix of interactively modeled geometry and coded logic. One of our customers who has taken great advantage of this capability is Premier Custom Build. They build luxury kitchens, and they created a beautiful system of custom features that call part studios that themselves use custom features. And the system lets them create an entire kitchen incredibly quickly using just a few of their features. Now, everything we've talked about so far has been about how everything should work in the ideal case. But we're only human, demigods at best. So we do have bugs, and the service occasionally has hiccups, and we plan for that. This is where our logging and monitoring infrastructure comes in. The first order of business is to make sure that Onshape stays up. Each of the machines that's part of the Onshape service reports its health to centralized dashboards, so anyone looking can see if things are working. Now, of course, at 3 a.m. on New Year's Eve, no one may be looking. So we have a large number of automated alerts set up so that if something goes wrong, at least 2 Onshape engineers get paged. Then we need to deal with bugs. For that, every machine in the system, but most of all the web servers, modeling servers, and geometry servers, are constantly producing logs about what they're doing, and especially when something goes wrong. For example, if you see a blue bubble with a support code at the top of the screen, we can just search for that string in the logs and see what went wrong. Or if you get unexpected behavior and go to support and support comes to us developers, we may try to find answers by searching the logs at the time you hit the behavior. And we'll also periodically search the logs proactively for errors that users are not reporting to us. And keep in mind that the logs don't have design information in them. We cannot see your design unless you share it with us. And then there's performance. When a user encounters repeated slowdowns with a document, we have the ability to trace the document. Then we can see what actions are slow and why. And we can also cross-reference traces and logs for further analysis. And we use that information to eliminate bottlenecks in the code or to suggest corrective actions to the user. So now you have a picture of where we are, but even more important is where we're going. Our architecture lets us build functionality quickly. In 8 years, we've basically caught up on CAD functionality while delivering many never-before-seen capabilities. So how can we do that with a much smaller team than our competitors have? Well, one factor is that our cost of a release is very low. Basically, every 3 weeks, we make a branch of the Onshape code, and QA starts testing every aspect of it. They flag any regressions and determine if new functionality on that branch is ready to go. Bugs are fixed on the branch, and functionality that is not ready is turned off. So this is a diagram of our servers running version 127 before we deploy a new version. This is the version that's running today. When QA says the 128 branch is ready, our ops team pushes a button and our automatic tools deploy the new machines. We switch over to them and shut down the old machines when they're no longer being used. We also launch a number of upgrade servers that go through and automatically upgrade your documents to take full advantage of the new functionality. And that's mostly it. No CDs to burn, no big installation headache for our users. If we find the new version has a serious issue that we didn't catch in the testing, we just fix it and push the button again. Of course, we have a lot of automated testing to keep the load on QA reasonable. And to make sure we haven't broken regeneration, we actually use your data. After making a release branch, we run the regeneration on production models and compare the results with the old code. If there are significant differences, that's a bug, and we look for public documents that hit the bug, or ask you, the users, to share your document with us so that a developer can take a look. Remember, it's just automated algorithms looking at your data. In order for a human to look, you have to share with us. So please, when you get a request to share your model, try to do so, as you're likely to benefit from a developer making sure we're not breaking your model. And we're also only developing for one platform. We let the people who develop Firefox, Chrome, or Safari worry about Mac versus Windows, graphics card compatibility, installers, etc. If we find a bug, we just fix it in the latest version of our code. We don't need to worry about that one really important customer who was running a version from 5 years ago because upgrades are a nightmare. And that leaves us to focus on new features, fixing bugs, and making Onshape faster. As John Hirschtick likes to say, these are still the early days and we're still just getting started. Some of you may have seen Jim's keynote earlier today. You can see PTC considers Onshape highly strategic and is heavily investing into our development. And despite the various challenges of the coronavirus, we've grown our team a lot in the past year. And I spend a lot of my time these days training new developers. We've also shipped a lot of new functionality since we've gotten acquired. One of the interesting developments is that we're using the cloud and data infrastructure of Onshape as a platform that we're calling Atlas. And it's a platform for other software like Vuforia for augmented reality. And we've also acquired Reality Server for photorealistic rendering, and we're putting that on Atlas too. And there are a bunch more projects like that in the works. And of course, we have a lot of improvements up our sleeve for Onshape itself, most of which leverage our unique architecture. It's not obvious from the outside, but we have a pretty deep project pipeline. That video in the What's New forum post might be the result of a few weeks or a couple of years of work. And we have some really exciting projects in flight. I can't talk about the details, as I'm sure you know we do cloud, not vapor, but go to Paul Chastel's talk right after the session for some sneak previews. And PTC has some amazing technology that we're going to be integrating into Onshape. So we're really looking forward to giving you ever better tools to make your product successful. Thank you. And I'm happy to take questions now.
All right, fantastic. Thank you so much, Ilya, for that peek under the hood at Onshape's architecture. So we'll now go to the Q&A section of this presentation. And we've got a couple of questions coming in from the audience here. So I'll go ahead and get us started off. Paraphrasing a little bit, you showed some of the architecture of all the different servers that are used. Just paraphrasing this question, what happens when many users start using Onshape at once? How is that handled? Would you be able to shed some light on that?
So this is something that happens to us every day, as you know, during the day, more people use Onshape than during the night. And the way that the process works is each one of the Onshape machines has what we call an availability score, which is roughly the measure of how many more users that machine can support in its role. And for every type of service in every region in the world, we look at the total availability score. So we'll look at the total availability scores of all of the geometry servers in Ireland, for example. And we have a threshold where we need to keep it above a certain threshold in order to support new users coming in. And as soon as the availability scores dips below that threshold, we'll launch additional machines to scale up the service. And as demand goes down, our total availability score will become much higher to the point where we don't need all of those machines. So we'll start marking some of them as unavailable. And then as users drain from them, unavailable means we don't route new users to these machines anymore. And after all of the existing users on the machines drain from them, then we can shut down the machines and save money.
Fantastic. Thank you so much for sharing that. One more question for you here. Again, paraphrasing a little bit. How you talked a little bit about Onshape running in the browser and the browser supporting aspects of it. How would you say Onshape is future-proofed? And what happens if the essential building blocks in the browser were no longer supported?
So this is something that we try very hard to keep up to date with. If browser vendors were to suddenly make major changes, the entire internet would break. So they have a very strong incentive not to do that. At the same time, we're keeping on top of all of the latest developments. We're constantly testing everything with new browsers. And so we're making sure that we're entirely up to date with all of the evolution of the software. We're using, for example, beta versions of all of the major browsers that we support to stay ahead in case we were relying on something that wasn't entirely standard and that gets changed and possibly broken in an upcoming version. We'll test with a beta version of, let's say, Chrome, so that we can be ahead of that.
Fantastic. That's great to hear. Okay, we have a few questions here about general Onshape performance. So we'll try to see if we can knock these all out at once. Some questions about latency, about running locally versus in the cloud, what's happening there. Maybe what I would paraphrase all of these together to say is, could you shed a little bit on light on what our users could do maybe to make Onshape run faster?
So performance is a really complicated topic because there are so many factors involved in, making any complicated system performant. And so some of the factors that the user has control over is their network and hardware. And so the first thing that every user should check is go to the browser check page, cad.onshape.com/check, and make sure of two things. One, that if they have a dual GPU setup, they're using a discrete GPU, because that is often not the default for a browser, and that causes slowdowns in rendering. And two, the other thing is that page shows you which region you're connecting to. So occasionally DNS providers and other ISP shenanigans happen, and you end up routed to a server that is not actually closest to you. And the browser check page will tell you which region you're connected to. And if it's not the one you expect, then you need to fix that, because you're going to pay a lot more for the latency than you need. Now, that's sort of the part that's under the user's control as far as sort of the basics. Assuming those two things are correct, for more complicated documents, if the user is still experiencing slowdowns, you kind of have to follow Onshape's best practices as far as modeling goes. So there are some things that you should avoid. You should avoid, for example, modeling a giant assembly in one-part studio. Even though our multi-part capabilities let you do that, that doesn't mean that's going to perform particularly well if you model an entire car in a part studio. Avoiding long derived chains, things like that. There are sort of a number of best practices to follow. very often, as long as you're connecting to the closest region, the latency itself is actually not going to be an issue. And then, of course, if you are experiencing repeated slowdowns, contact our support. They have the tools to help you, and to go to us if they can't help you, and we'll figure out what's causing the slowdowns.
Fantastic. Yeah, certainly great advice to reach out to support for specifics. If you're able to share data with us that we can look at, we can certainly give much more tailored advice. And one other question that you kind of addressed in there as well about part studios, when to kind of split them out or when to have multiple parts within a part studio, of course. So I think that's great advice as well about that.
And the performance advisor that we just shipped can also help with that, actually.
Yep, fantastic. Great new updates. We have a couple of questions about FeatureScript, so I'll try to group these together as well. So first off, what would you recommend for users that are interested in learning more about FeatureScript and getting involved in that? And then what do you see as sort of the future for FeatureScript, if there's anything that you might be able to share of how it would be continued to be applied for Onshape and Atlas in the future?
Yeah, great questions. So I'll start with the first one. So our documentation portal is the best resource for learning about FeatureScript, at least for getting started. We have a couple of tutorials that we have there that are really worth going through, and they will sort of force you through the basics. And once you've done that and are trying new things and experimenting, and it's always safe to experiment, you're not going to break anything. The best resource for FeatureScript has been our forum. Us developers, my team monitors that forum. We have a number of wonderful users that monitor this forum and are happy to help people getting started with and learning FeatureScript. So that's sort of the learning part. As for the future of FeatureScript, there's sort of a number of directions. So FeatureScript is currently primarily used as a regeneration language, although we've also started using it in some new roles. For example, in the past year, we've released custom tables, which also leverage FeatureScript to allow you to produce customized tables based on the data in your part studio. And one of the ways that we're building out FeatureScript capability is there are going to be more of these roles that FeatureScript can play. Well, I don't want to spoil the sneak peek, but the sneak peek is going to show one of them. And then, of course, there are a number of improvements that we want to make to FeatureScript, as far as making the tooling better. If you can, the FeatureScript IDE is never good enough. Improving performance and rounding out some of the functionality as well.
That's fantastic.
Thanks, Ray.
All right, I'm seeing questions flying in here, so thank you guys so much for your participation. I'm going to apologize that we're probably not going to be able to get to all of these, but between Ilya and myself, we'll be sure to reply to any of them privately we're not able to address here in this forum here. A couple of you had asked about parallelism in the cloud. So Ilya, I'm not sure if you can address a little bit about that. Are we using parallelism in the cloud? And if so, where?
So that is a good question, because that is one of the big promises of the cloud. And we do use it in some places. So to give an example, if you have an assembly and you've got multiple different parts in that assembly, and some change is made to all of these parts that requires all of them to be regenerated. So that regeneration will probably be done in parallel. It will be done in parallel, most likely on multiple different geometry servers. And there are also, we have plans for making more use of cloud parallelism for things like engineering design studies, where you can test out a number of different analyses, things like that. Now, certain aspects of CAD, on the other hand, are sort of inherently serial. So there is a fundamental limitation there in that you can't really regenerate. There's certain types of features that you just can't regenerate until you've regenerated all the features before. So regeneration itself is inherently serial for the most part. And well, because of that, for example, we make sure to rent the Amazon machines with the highest single thread performance that we can buy.
Fantastic. Thank you so much for that. So both John and Jim talked a little bit about Atlas, and I've seen there's quite a few questions in here about that as well. So I'm not sure if there's any information you might be able to share about Atlas itself, how it might integrate with Onshape, how it might integrate with FEATURESCRIPT, or really if it is sort of something functional today. Maybe if there's any details you might be able to share or sort of our future vision with regard to that, that would be great to address as well.
I am probably not the best person to ask this question. Andrew Kimpton is head of our Atlas initiative as far as R&D is concerned. What I can say is that a lot of the concepts as far as how the data is structured that I talked about, the incremental edits, the database sort of the append-only writes, the versioning mechanisms, etc., they're going to be the foundation, or they already are the foundation of Atlas's data model. So it really is going to be using the same code that we use to do our version management. There also, there are going to be aspects of Atlas that are not currently part of Onshape, and we're developing more of that to deal with an ecosystem of, applications more than Onshape currently has. So that's sort of where a lot of the effort is currently going as far as building it out.
Fantastic. Yeah, absolutely. Sort of how John had described, right? It being the basis for a lot of these other applications that'll be built on top. Awesome. One other question here. You started to address this a little bit on FEATURESCRIPT, but as you see more functionality being sort of integrated into Onshape, ECAD, simulation, rendering, do you see plans to have that accessible to scripting as well?
Sorry, I missed that.
I recognize this is a bit of
to have what accessible to scripting?
Other integrations such as ECAD, rendering, simulation. I recognize this is a lot about future plans as well here. So just if you have any details you might be able to share.
So FEATURESCRIPT is not the only mechanism of automation for Onshape, and it's one that is very specifically tailored for part studios, and for a lot of other things it works well, but it's not necessarily the best thing for scripting an overall system. So for that, we have API capabilities that we're also improving, especially in light of Atlas development. And I think the expansion of these API capabilities is what's going to make for a really convenient system to automate things like ECAD and rendering, simulation, etc.
Awesome. It's fantastic. Okay, one of my favorite questions here, very broad one, but good one to address as well here. How do you decide which functionality gets built into Onshape next?
That's an interesting question. It's a bit of a juggling act, and we're essentially, on the one hand, we have what we think is important to do, and on the other hand, we have a finite set of developers that are able to implement the functionality. And so what we think of important, well, the most important thing is obviously what is blocking our existing customers from doing their work. So as much as we can help existing customers, that functionality gets prioritized. Other things, next in priority, for example, is functionality that'll help us acquire new customers. But we have to, as far as priorities, while doing that, we have to continue investing in performance. We have to continue investing in fixing bugs and maintaining quality, and also code infrastructure and code cleanliness. And so we have to kind of make time for all of those in addition to delivering the functionality. And now if we just did all of that stuff, well, it would still be kind of boring because, a lot of what makes Onshape unique, FEATURESCRIPT we wouldn't have, branching and merging we wouldn't have. So we also make sure to leave some amount of room for innovation and for risk taking, and for projects that, our users may not think they need today, that they're not, necessarily asking for, but we still leave room for those projects. And on the other hand, we have, the available developers. We've got a wide range of skills. So for example, we're not trading off drawings development versus geometry development versus UI development, because that's going to be different groups of people doing that work. Then on top of that, we have summer interns. We've got a wonderful intern program, and a lot of our functionality that love was actually developed by interns, and that lets the intern program lets us have smaller, more bang for the buck type projects, or more innovative and risky projects that we do over the summer. And if you follow our releases, then you can see that towards the end of the summer or the fall, we might have a little bit more of that type of functionality, creature comfort type stuff.
Fantastic. Yeah, thanks for some details on that as well. So I'm looking, it looks like we are coming close on time here for this session. So once again, I am seeing that there are quite a few additional questions in here. We haven't been able to, some of them very user specific. And once again, what I'll promise is certainly Ilya and myself will get together and we'll promise to write you a response to those here in the chat. But other than that, I think we will plan to wrap up this session at this point. So thank you all so much for your participation. And thank you so much, Ilya, for hosting.
And thank you, Roy, for moderating. And thank you, everyone, for listening.